This is from Chapter 5.4, Probabilities for Sampling Distributions. And it says the data was collected on the average daily driving time for different age groups. The mean driving time for people in the 15 to 19 age group is 25 minutes. That's your mu, stands for mean. This is the data collected from a random sample of 50 people in this age group. The standard deviation is 1.5 minutes. What is the probability that the mean time they spend driving each day is in between 24.7 and 25.5? Now, there are 50 random samples in this age group that are chosen. And since your sample, which is n, is 50, 50 is greater than 30, so you can conclude that the sampling distribution of the sample mean is approximately normal with mu equal to, and excuse me, this bar should have been somewhere else. Actually, let me see if I can get in there and move it. It should have been over the x here, and this bar should have actually been over the x here, and I moved something down, and that's why it moved it. Anyway, it's going to be the standard deviation divided by the square root of the sample size. So my sample size is 50. This is my standard deviation. My mean is 25. So this is the central limit theorem, and I'm going to show you how to work this on the calculator. So these are the numbers that you want. You want 24. Your interval is 24.7. That's your lower bound. 25.5 is your upper bound. And we're going to go to the calculator in just a minute, and I'll show you this. So we're going to go to the normal cumulative distribution, and that's going to be the lower bound, the upper bound, the mean, and the standard error, excuse me. And the way you get the standard error will be 1.5, which is the standard deviation, divided by the square root of your sample size. So this is what I'm going to type into the calculator, and when I do, I'm going to get about 91.91 is the probability that that's going to happen. So most people between 15 and 19 drive about 91% of them drive between 24.7 and 25.5. So I'm going to go to the calculator real quick here, and I'll go to second distribution and down until you get to your normal cumulative distribution here, and the lower bound is 24.7, comma, the upper bound is 25.5. The mean is 25, and the standard error is 1.5 divided by the square root of 50, because your sample was 50, and close that parentheses, and I would close the other one, but it'll work whether you close both parentheses or not. And there's your answer, so it's 0.91. Remember that sometimes the calculator doesn't give the same answer as if you work it by hand because of the rounding. So if you ever do get an answer that's very close and it's counted wrong on my stat lab, if you'll just email me and tell me which question it was, I can go in and fix that and tell me what answer you got.